So following on from the previous video, we were trying to find out the derivative of the inverse tan of x, and we got to a stage where the graph for the inverse tan of x looks like this. So to differentiate it, we would start with this here, and then we would tan equally to both sides. So when you tan equally to both sides, it will look like this. So you would start here, and then you would tan equally to both sides. So tan this and then tan this here. These two would cancel each other out, leaving you this. So from here you would tan both sides. It would take you to here. And by the way, you can do this move. Starting from here, you can tan both sides equally to get you from here to here. Because if you think about it, when we first started out doing trigonometry, we had a right angle triangle like this, and x let x represent the angle here. So tan of the angle here equals the opposite over the adjacent. Okay, and then if you ever want to know, so from here, if you ever want to know the angle itself, you would inverse tan equally to both sides. So that would take you. It's what we've been doing all along here. Because the reason for that is whenever you have a function, and then you apply the inverse of that function, it will then give you what you originally put it into this function here. Remember this. When we first started out this, we made this point here. Whenever you have a function here, if you apply the inverse to that function, you would get x. And also, even if you start with the inverse here, which is our case here, we started out with the inverse here. And then if you apply the tan to the inverse, then these two would kill off each other, leaving you. Well, the point is that from our section on functions, if you ever have a function here and then you apply the inverse to that function, you're just gonna get what you originally put into the function. Same as if you already start with the inverse and then you apply the normal function to that inverse, you will get back what you originally put into the inverse function here. And that's another way of thinking of that is like you've got a function here. If you put x into this function, let's say it spits out y, and then if you put y into the inverse of this function, you're just going to get back x. And the same with if you start. So up here we started with the inverse. Even if you start with tan here, if you put x into here, let's say it spits out y, and then if you put y into the inverse, then it's going to spit out what you originally put in. The point is that the point is this bit here. This bit here is a key step here. Okay, so hang on. So so originally we would start here, and then in your mind tan equally to both sides, and then immediately jump to this here.